Hello, today I want to talk about digital sensors. And in this case, it's a digital temperature and humidity sensor. And what you can see in front of you is an eBlocks 3 board with a graphical display. And on port B, what we've got is a small digital temperature sensor. It's a tiny little chip. You can just see it in front of my fingernail there. And in series with it on port C, what we've got is a little interface board and a logic analyzer, an 8-channel logic analyzer. And we'll look at that in a moment. And the program takes in the temperature digitally and displays it on the circuit board. It's a very warm day here today. It's about 27 degrees in my office. So when I put my finger on it, it's not moving a great deal. But you can see that it is working there, and the program shows the temperature on the display. Let's look at the software behind that first. I'll just minimize that. So here is the Flowcode program. On the panel, I've got a temperature humidity sensor on port C, and we're using it in software mode with the I2C clock on C bit 5 and data on C bit 4. I've also got a touchscreen display, which is built in. And here's the program. We initialize the screen and the sensor. We print temperature indicator across the top, and then the little C text to the right of the display. Then in an endless loop, we get the temperature in a variable called tempint. Tempint is type int, and we're using that because it can go negative and positive. And then we're printing tempint on the display, and we're using font type 6, which is a large font. And then we're delaying for 1 second, and we're going around in an endless loop. So the program is relatively simple. Let's look at how the data is transferred between the microcontroller and the temperature sensor. To help us do that, what I've got is a logic analyzer, and the program is running now. And if we play the program and stop it, then what we should be able to do is we can see the data exchange is happening at around 1 second intervals. And zooming into that, we can see how that data exchange works. Something you should note on the program is that the sensor has an address of hex 44. 0x means hex 44. That is the address of the temperature sensor in terms of the I2C. So what happens is the computer at 1 second intervals says for the device addressed at hex 0x44, command E0. The command is different for every single sensor, but if you looked this up on the datasheet, E0 would be a command that says, give me the temperature and the humidity. So this is sent to the chip. It's received by the chip, which then says, from device at address hex 44, here are 3 bytes corresponding to the temperature and 3 bytes corresponding to the humidity. Now, the structure of data after the read command is going to be different for every single type of sensor. And what you need to do is delve into the datasheet to try and understand that. But in this exchange, you can see from a systems point of view, you've got a request for information and a return for information. And from a data point of view, you've got a clock line and a data line. On the rising pulse of every clock, the data is valid. So that's when the chip knows when to sample the data. And it puts together the appropriate information. So this shows you how I2C is used in a serial data communications way to build bigger systems. And it's a bit daunting to start with, but actually it's really quite straightforward because the Flowcode program takes care of all of the details of the serial communication for you. Okay, that shows you how to use a digital temperature sensor. Thank you for watching.